Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Says that we have a frequency F1 when a mass M1 is hanging from the object. We don't know M1, but we're told F1 is 12 hertz. We then add mass M2 to the spring. So our new mass is going to be M1 plus M2, and we have a frequency of 4 hertz that time around. So F2 is 4 hertz. And we're asked to find the ratio of M1 to M2. Okay, to do this, we're going to consider the fact that the angular frequency omega is equal to 2 times pi times the frequency f, but the angular frequency omega is equal to the square root of k over m. So since k is the same, we're using the same spring in both cases, and we know f, we should be able to find the relationship through the ratios using this relationship. So in general, we find that m is equal to 2 pi, 1 over 2 pi f squared times k. All right, so in the case when we have the first mass hanging from the spring, and that's it, we have m1 is equal to 1 over 2 pi f1 all squared multiplied by k. And in the second situation, when we have frequency f2, we have m1 plus m2 is equal to 1 over 2 pi f2 squared times k. But since we want to find the ratio of m1 to m2, we need to get m2 by itself. So we need to subtract m1 from the left side of the equation over to the right side of the equation. So we subtract m1, so this becomes m2 is equal to that value minus m1, and we're going to replace m1 with the expression we have on the left. So what we end up with is m2 is equal to, well, the k and the 2 pi squared are going to be the same for both, so we can pull that out front. So we have k over 2 pi squared times 1 over f2 squared minus 1 over f1 squared. Okay, so now that we have an expression for m1 and m2, we can go ahead and find the ratio of m2 to m1. We'll do that on this page. So when we find the ratio of m2 to m1, we notice that here, let's go back here so I can show you what I'm talking about. We notice that m2 and m1 both have the k over 2 pi squared values. And since those are all the same in m2 and m1, they're going to cancel, and we're going to be left with just the frequency terms, which we have numbers for, so we can get an actual number for this ratio. And what this gives us is, the first one gives us m1 is gives us our f1 squared, but it's a 1 over f1 squared, so the f1 squared ends up on top. And then on the bottom, we have, in the first case, we have 1 over f2 squared minus 1 over f1 squared. So this is f1 squared over f2 squared minus f1 squared over f1 squared. So if we plug our values into this expression, we find that this comes out to equal 8. We can box that in as the solution to our question.